All right, here we go. Let's do a quick review of Unit 4. We're talking about function algebra here. So let's take a look at everything we did. First section, we talked transformations, and I'm just going to kind of throw some examples out here. A lot of times we start with this parent function. So here's a square root function. I'm doing these different things to the function. So let's go ahead and write the equation of this. So if I'm going to do a vertical reflection, remember the key to this is vertical things happen outside the grouping symbol. In this case, it's a square root, a lot of times it's parentheses. Horizontal things happen inside the grouping symbol. So a vertical reflection is going to be on the outside. So I'm going to even change my color here and say vertical reflection is going to be, and I think I was really writing this about the x-axis. So something about the x-axis, there's a vertical reflection. I'm going to have a negative out front, and then I'm going to go to my grouping symbol here, which is a square root, and have a horizontal stretch. So I'm going to stretch it. Remember, inside the grouping symbol is opposite of what you would think. So if I stretch it 5, I'm actually going to write 1/5 x in here. So it's opposite of what you would think. This means you're going to stretch it 5. Then it has a vertical shift down. So there's no more horizontal, no more shifting. But I'm going to do a vertical shift. That looks like it was in green. Down 3. So I kind of color coded it there. That's pretty nice. Pretty nice. Each part of it. Excellent. So what if I give you the function right here is a cubic function. I ask you to identify it all. Remember, we like to have I like to factor out this negative. I don't like negative x in there. So if I factor out a negative, I'm going to rewrite it so the negative comes first. This turns into -5. So you kind of have to factor that out. So we like plain old positive 1x to start here. The reason we like that is now we can look and say, oh yeah, what are the different parts? So this is going to be a vertical stretch. I'll put stretch of 2. Because it's on the outside of the grouping symbol. That's some awesome handwriting right there. Then when we go to the inside here, this negative right here is going to do what? This is going to be a reflection about the y-axis. So a horizontal reflection because it's inside the grouping symbol. Now we've got another horizontal shift. Which way? Now I took the negative out. I can see it actually goes right 5. And then outside the grouping symbol, so I know it's vertical, this will be a vertical shift up 1. Excellent. So I kind of gave you another one here to look at, some more things going on. So in this case, we actually have a vertical shrink of 1/4. So when it's on the outside, it's normal of what you would think. On the inside is where we got issues. Again, I've got a 3 in front, so I'm actually going to rewrite this as 3 times x minus 3. So I've got an exponential function raised to this power. So now I can see inside there, oh yeah, this is actually going to cause a horizontal, and it's opposite of what you would think. Anything in the grouping symbol is opposite of what you would think. So that's a horizontal shrink of 1/3. And I'm going to have a horizontal, it's in the grouping symbol, shift what? I'm going to shift right 3. And then I've still got that vertical shift at the very end, down 7. So you're going to have to be able to recognize all that fun stuff. Maybe graph one here and there. I love it. Transformations. Then we moved on to even and odd functions. What makes them even or odd? Well, there's a handy dandy formula. Remember, if you put in negative x to the function, it needs to equal the positive x. That's what's happening here. This is negative x. It should equal the exact same thing if you went out here positive x style. So they should be the same exact point if you put them in. So this is the rule, so you may have to prove it algebraically. And this causes what kind of symmetry? Well, these, when you look at the graph, are symmetric. How? They're symmetric about the y-axis. So sometimes you got to prove it algebraically, sometimes you got to just look at the graph here. How about odd functions? What's going on with odd functions? Well, you're looking at the f of negative x, so you're looking at something over here. If this is negative x over here, remember something over here, they're opposite signs. So what happens here? This is the negative f of x. So these two values are the same. The signs are just different here. So what that does cause some kind of symmetry. What symmetry do we have here? This is symmetric about the origin, or sometimes it's called point symmetry around this point, the origin. You're spinning it. So this top little piece over here spins around and becomes this little piece over here. So those are even and odd functions. Awesome. Moving on. So we've got the next section was on operations with functions. We start with this idea of composition of functions. So we have the f of g So you're putting g and f, and if I put in a variable, it's the f, that's an open circle, something like this. And what does that really mean? It really means the f of g of x. So we're plugging one function into another one. So real quick, just remember there can be domain issues with this. So you got to check out the domain. So a lot of times I look at the domain right off the bat. What's the domain of this bad boy? Well, it's got to be what? You got to set greater than or equal to 0. So this should be what? Anything bigger than -3 is Coolio. Go smaller than -3, we're going to have issues, can't take square root of negative. Here, the bottom can't equal 0, so what would make that 0? It looks like plus or minus 2. So in this case, it cannot equal plus or minus 2. So if I was trying to find the f of g of x, remember I'm going to say it's going to take the domain of this. It's going to take that limitation plus whatever happens when I plug it in. Holy cow. So let's go ahead and do one. Let's plug that bad boy in. So if I'm plugging g into f, I'm going to replace every x with my function. So g of x is square root of x plus 3. I'm going to plug it in here, x plus 3, and then I'm going to square it, minus 4. And when I square the square root, it cancels out. So I'm looking something like this. I've got 4 over x minus 4. So if you just looked at this function, that is the f of g of x. If you're just looking at 4 over x minus 1, we say, okay, what's the domain here? Well, the domain, x can't be 1, right? Because that would make 0 on the bottom. So you're saying, yeah, it can't be 1. But what else? You have to go back to the original function you plugged in there. You have to include all of this. So it's both of them together. So I prefer interval notation for this. So I'm going to say it's everything greater than -3 till it hits 1. It cannot be 1. Then it's going to be 1 to infinity. So I'm combining this all together. So this is the function, this is its domain. Most restrictive domain possible using the g and then the new function here. So this didn't bother us. Now, would this bother us here? Yes, if we took the g of f of x, you would do the same thing, except now you're using this restricted domain when you plug it in there. Holy cow, I love it. Moving on, then we did a lot of operations. Remember, you can add, subtract, multiply, and divide. And if you put it, that's just general functions. If you put it with respect to x, it looks a little crazy, and my handwriting is pretty awesome. Like this. This is when you do it with respect to x. So don't freak out either way. A lot of times we'll just put a point in there. So a lot of times I'll say something like, what is the f minus g of 2? Those are nice because you just plug in 2 for, find the f of 2. 2 times 2 minus 1. And then find the g of 2, and then you just subtract them. So when it's evaluated at a point, it's pretty awesome. This is just going to be 3. This is going to be 4, 12, 7. So 3 minus 7 is -4. So that's pretty cool. If I do it generically, you do have to worry about domain, and usually with this bad boy right here, when I talk generically, if I'm going to do the f divided by g, so really let's just do that one. The f divided by g would be 2x minus 1. All over 3x squared minus 5. So I do have domain issues here. It would bring them in. If there happened to be a square root up here, you would bring in that restricted domain with it because you're still using those functions. So what does this bottom equal here? It's going to say this can't equal 0, so you actually have to solve that equation. So I did not make this one very friendly, but you can solve this. It's going to be 3x squared cannot equal 5. Divide by 3, and then square root both sides. So in this case, x cannot equal plus or minus radical 5/3. So sometimes the domain is an issue with operations even. Awesome. Moving on, then we wrapped it up with inverse functions. So how do you find an inverse function? Well, you switch the variable. Remember, you switch x and y, and then what? Then solve for y. So you switch x and y and solve it. How do you prove it? Well, we got to use our compositions of functions. We got to say the f of g of x equals the same thing as the g of f of x, and I know what they both equal. They both equal x. So if you plug one function into the other function, it's going to equal plain old x. What does that turn out to be on the graph? Well, if you look at it graphically, what happens here, this is symmetric, isn't it? It's symmetric around this line right here. Boom, 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 boom. So these are two inverse functions. They're symmetric about y equals x. So we do have symmetry here, symmetric about y equals x, and then you can start to plot these points. So like, it's hard to find a good one on this. Well, here's one. 0, 1 becomes 1, 0. How about that? You're just switching x and y, right? So you switch x and y, it's going to switch x and y on all these points. So what does that mean, the domain? Well, for the domain of my function, the domain of my function and the range of my function switch for the inverse. So, oh my goodness, what is that? This is the domain and range of this. So whatever happens here, the domain of my function will actually switch with the range of this and vice versa. Because remember, this is x and y, you switch x and y. So it makes sense. Everything goes along those lines. Awesome. So if you need extra review, go ahead and just do the corrective assignment first. It has more problems for you to check out. If you feel pretty good about it, just do the real quick one-page review. Good luck on the test. Peace out.